Hello everyone and welcome to SolidWorks video on part files. We are going to start with some sketch tools and strategies that I recommend for your consideration in SolidWorks. There are quick and informal ways to sketch in any CAD tool, and then there are some really good kind of best practices that make it easy to keep track of your design intent and make it easy to change parts without breaking them, kind of thing. So we're going to look at that in SolidWorks. I'm already in SolidWorks. I have a part file. The first thing I'm going to do here is save it. And I highly recommend that the first thing you do is save your part file in a place where you know you have access to it later. So you should be using something other than your computer's hard drive. All of the computers are programmed for deep freeze, meaning files are erased regularly. If not every night, then at least every week. So never assume you can save to the computer. If you save to the computer temporarily and at the end of every session, upload it somewhere, that's fine. Flash drive might be a good idea. So the first thing I usually do is save so that I know it's saved. And I'm using my ribbon toolbar here, and I'm just going to start a new sketch by clicking the sketch tool. And I'm going to now choose a plane on which to sketch. And I had meant to choose the front plane there, so I'm actually going to, I don't want to sketch on the top plane, I want to sketch on the front. So I'm going to go ahead and hit this X to start over. The red X discards my sketch. I'm going to try this again. I would like the front plane. There we go. So the first thing I would point out is where you can find tools. Your line tool is here. Your rectangle has a couple of options. For example, you can choose to start or define your rectangle by its corners or by its center in one corner. There are some other custom rectangles available. We have circles, whether you define that as its center and its outside or 3 points along its perimeter. It's up to you. There are arcs. There are polygons. And that's most of our basic sketch tools. So I would say pretty much everything we want is right here. Although, straight slot, I missed that one. So in SolidWorks, you can actually just put in slots where you define the two center points for the end semicircles and then the width of the slot. So that's a pretty convenient tool as well. So on this one, I'm just going to make a simple rectangle. What I'm hoping to make by the end of this is all of the different pieces of a bearing plate without the exact dimensions of your assignment so that you can modify it as you see fit. So I'm going to choose my rectangle. It's defaulted to the center rectangle today, but we'll show you both of them. So the center rectangle means that I can choose the center point of my rectangle and then I choose the outside of that rectangle. A rectangle has two sides or two pairs of sides that are each equal length, right? So these two match and these two match. If I wanted this to be a square instead of a rectangle, I can actually add constraints there. So if I know that I want this to be a square, I'm going to use the control key on my keyboard. So I'm holding the control key down and then I'm going to click two perpendicular sides. And now here are relationships I can add. They're already perpendicular, so that would not add any intelligence or any information to my sketch. I couldn't use horizontal or vertical because one is vertical and one is horizontal. Collinear also would break the sketch, as would parallel, but I can make them equal. And that's going to mean that if I change the length of this side, it changes the length of the perpendicular side as well. So all I need now is a single dimension. So I'm going to click my Smart Dimension tool. I click on this side once. I move my mouse away and I click again to insert the dimension. And now I'm going to say that this will be a, let's say, 1.5 inch square. Okay. So there we go. I have a 1.5 inch square. And the center of that square is right on the origin, and both of my sides are equal length. Okay, so let's say I wanted to, add a circle somewhere on this square. I would choose my circle tool, and I could choose the origin here to have that circle centered on my square, and I could now click on the outside of the circle to put in the actual shape of the circle. So I chose the center point and the outside. I can change its diameter. I can define its diameter. So maybe that's, you know, a 1-inch circle. And that circle is stuck right on the origin, so it can't move around. And so now let's talk about some best practices. The first thing I want to point out is that all of the lines on this sketch are black. If something is blue on a sketch, it is underdefined. If someone comes into my sketch after me and just casually touches and clicks on the outside of the circle, they can change that diameter without even realizing perhaps that they did. If I click on this circle and I define it over here as a 1/2-inch radius or a 1-inch diameter, okay, it's still blue, but I dimensioned it. This is not a dimensioning tool. This is simply a guideline. This is setting the dimension, yes, but it's not freezing the dimension. And so that's still blue, and this is still underdefined. Down at the bottom of your screen, it tells you if it's underdefined. So I highly recommend fully defining all of your sketches before you continue. So I'm going to put my 1-inch dimension again. It didn't change size, but it did turn black, and now it's fully defined. So best practice sketch number 1, always fully define your sketches. Do not rely on parameters to set your lengths. Use the Smart Dimension tool. You're less likely to accidentally change your part, and if someone else is looking at your part. So you sent this to a customer or a boss or a colleague, you're working in a team, no one else can change it without realizing. I have to double click on, or at least click on the dimension and type in a different number to change that dimension. I can't accidentally drag it to a different dimension. Okay, so that's best practice number 1. Another good rule of thumb is to put in your relationships before you add your dimensions. Your relationships might be more important, but they also often simplify the dimensions that you need. So I've never found a situation where adding all of my geometric relationships first and then adding dimensions second cause problems, but I have found some of the flip where if I dimension everything and then I add relationships, that can cause problems. For example, that equal relationship, that's design intent. If someone walks into or opens up this design and looks at that equal constraint, they can say, this designer intended this plate to be a square, and I will have to think about whether I want to remove that particular feature. And I have to be intentional about it. If I had, instead of adding a constraint, simply dimensioned it to be 1.5 by 1.5, someone who doesn't know my intent walks into this drawing and says, I'm not sure if it has to be square, if it was intended to be square, or if that's just a coincidence based on these measurements. And they could just change this to 1.75. It's no longer square, and maybe that doesn't work as well for my design. So design intent matters, and design intent is usually best defined by geometric relationships. I'm hitting the Control-Z for undo. You could just as easily hit this undo up here, and I'm back to my original sketch. Okay, so the final thing I want to show you is just a couple of these other tools, how they work. So if I was to choose a corner rectangle, you choose one corner and then the other. It's a pretty intuitive tool. Otherwise, it works exactly the same. A slot, I did want to show you how this works. We choose one center point of the arc, another center point of the arc, and then we choose how wide the slot is. And when you dimension slots, you have to give a radius to this side. So let's say 1/8 of an inch. And you also have to give a length of the slot, 1 inch. And the reason it's still blue is only because I can move it around in space. It's not stuck on the origin. Otherwise, that would be fully defined. And I think that's it for basic sketch tools and strategies. My final sketch strategy to mention here is keep your sketches simple. It is easier in SolidWorks to make a series of sketches and a series of features that add up to the part you're trying to make than it is to make one really complicated sketch. So if I had a bearing plate with bolt holes to hold it onto wherever it's attached, plus the bearing hole and the information for the plate itself, all of that in one sketch is a bigger file in SolidWorks, and it's also harder to make changes later. In fact, I'm going to go ahead and take this circle right out, and I'm just going to make my bearing plate. And I think I'm going to make it a 2-inch bearing plate here. So I'm just going to make my bearing plate for the next part of this video. Once I have my plate, I'll cut my bearing hole and cut my bolt hole pattern. So it's a little bit easier to manage each feature and to change them separately rather than trying to figure out exactly which dimensions go with which feature in a single sketch. Okay, so now we're going to look at how we extrude and revolve in SolidWorks. Oops. So we have our basic sketch. We're going to do an extrusion first. I'm going to show you several ways to do this. The easiest being, once we have our sketch ready, we just come here on the Features toolbar, click Extruded Boss Base, and now it gives me all of the options for that extrusion. So you can see this is extruding from the origin forward. I can choose to make a mid-plane extrusion, which means that the origin stays in the center of the part. I can choose a single direction and then change it so the origin stays on the top or bottom. Another note here is if I wanted to, I could start my extrusion at an offset from my sketch. Not particularly helpful in this case, but I just want you to know that that is something that we can do. And I think we have, well, let's assume we have 1/4 inch aluminum there in the shop. So I'm going to make this a 1/4 of an inch, 0.25 inches, and there is my extrusion. If you only have a single contour, this automatically selects that contour. If for some reason you had multiple contours, so last time when I had that circle in the center, I might have to select exactly what I want to extrude. SolidWorks does this more simply when there is a single feature to extrude. Generally speaking, checkmark puts it in SolidWorks, so click that checkmark and you have your feature. Now, I'm going to undo that and show you another way to get into an extrusion. So let's say we were in our sketch and we returned out of the sketch using the Save Sketch icon, that's the blue arrow. And now I'm just in a gray and white. I'm in the part file. My sketch is gray because I'm not in an active sketch, but I'm also, when I click Extrude Boss Base, it doesn't know what I want to do. So now I can just click any line on that sketch and again, choose all my features here. Checkmark puts it in. If you want to edit a feature later, you can just click on the feature. Oops, sometimes it tries to change the name. So then click on the icon and you can edit the feature. So let's say we wanted to change the depth of the extrusion or the direction of the extrusion, we could do that. And checkmark saves your changes. Finally, a really useful tool here can be, so edit sketch would edit would go back in to edit the sketch. We can also edit the sketch plane. So remember in the beginning when I chose the front plane, if I decided I really wanted to rotate this part so that it sat flat on the top plane, this is the screen in which I would change my plane. So maybe I want to change to the right plane, and it just rotates the sketch to sit flat on that plane. So edit sketch plane is, if I click on the sketch and I click on the sketch plane, edit sketch plane tool, I can fly out my part tree and change the sketch plane. If you hit the isometric view, either on your heads up or in your standard views toolbar, and it's not facing the direction you want it to be facing, that's usually the first place I go to try to fix that. So that's the basics of extrusions. So now we're going to take a look at the revolve feature, which won't be helpful in my bearing plate, so I'm going to end up putting this back in, but I want to take a look at how a revolve works. So let's say I wanted to make a cylinder out of this. So I have sketch 2. I'm actually going to pre-select it, come up here to revolve boss base, and let's see if I can get this to revolve about one of its sides. There it goes. So it's going to give me a preview. I can choose how much of a rotation I get, so I don't have to go all the way around, right? I could make Pac-Man, but more typically we're making a full revolution. Imagine things like a tire or donut or spheres I would make with a revolution. Cylinders can be made with either a revolution or, of a square or an extrusion of a circle, right? So this is just another tool in your toolbox. Checkmark puts it in, and there's my revolve. Okay, so I'm now going to go back and just extrude that square quarter of an inch, and that's the basics of using the extrusion and revolution tools in SolidWorks. So now we're going to take a look at cutting. We might be cutting external profiles. We might be cutting very simple through features like holes. For the most part, I don't use the cutting tool for hardware holes, but we will take a look at how we can cut in general. So here I have my plate, and now I'm going to go ahead and cut my bearing hole using a cutting tool. Bearing holes, I think, are the only holes I would use the cutting tool for. So first, I'm going to select the face that I want to cut and come to the sketch toolbar and start a new sketch. And the next thing I'm going to do is I really like to be normal to the surface before I start sketching. And I'm trying to find that on my heads up. Usually there's one here. I know there's one right on my standard views toolbar, normal to, or I could have chosen my front view. I find it hard to sketch in 3D, so coming normal to means that I'm sketching in 2D again. And here I just want a circle for my bearing to fit in. So I put my circle, I want it centered, so I'm going to put it right on the origin, and I'm going to give it a diameter, again using smart dimension, not the parameters on the left. So let's say I have a 3/8 bearing, so it would fit a 1/4 inch shaft. It's a 3/8 outer bearing, and it needs a hole in this plate. So I'm going to put in the dimension. I check that it's fully defined. And now I come to my features toolbar and I can perform an extruded cut. An extruded cut has a number of options just like an extruded boss base feature does, only in this case it's removing material rather than adding it. Again, I can change if there's an offset. I can change my direction to mid-plane, a certain amount blind, a certain distance just straight through the part. I can also choose to cut through the part, and that's the one I'm going to choose here. If I flip side to cut, it's going to cut everything outside of my sketch and it would leave this cylinder. Not what I want in this case. If it's cutting the wrong direction, I can change my arrow here. And if I, for some reason, wanted to cut in 2 directions but not through all, I could. SolidWorks has this really great new feature, through all both, that would take care of that for me. That's relatively new. And I think that's all we need about this cut feature. And I'm going to show you the difference between a cut for something like a bearing hole or an irregularly sized hole versus a hole that's for hardware. Hole, if it's intended to be for hardware, whether it's a screw or bolt, or it's going to be threaded or clearance. If it's for hardware, I don't use the cut tool because this is a dumb cut, in that it doesn't store any extra information. It's just taking material away. A hole wizard saves a whole bunch of different information. Cuts don't have to be holes. I could make a sketch here on the front that, for example, maybe I want to, oops, that's not going to work. Let's add an arc, a 3-point arc. We're going to put, I'm going to, I want to make this curved, so I could make an arc, and then I would have to close my feature. So I would come up here and close my feature. You'll notice, and actually I should have been a little bit clearer about that, when I am trying to put a point on a line, there's this extra yellow point there. That is the midpoint of that edge. And if I snap to it, it snaps stuck to the midpoint. And that will give me a nice curve at the top of this. And I think I can make this tangent, that arc tangent to, so I'm going to hold the control key, select the arc, select the edge, and make it tangent. There we go. So now if I choose features and cut, I can select the contours I want to cut. So I'm going to not select this contour, but this one. And this one, checkmark puts it in, and so now I've kind of made a rounded bearing plate. If I wanted to suppress this, just to go back to my square, I can. If I wanted to delete it altogether, I tend to use the delete key on my keyboard. So just trying to show you that a cut can be any type of feature on your part. Okay, so that I think is everything you need for now about extruded cuts. So let's take a look at hole wizards. Hole wizards, again, are for anything that is intended for hardware. So important thing about hole wizard is much easier if you pre-select the face you're going to put your holes on. So I select the front of my part, I come here for a hole wizard, and now I have two tabs, type and positions. Positions are where the holes will be. Types are going to define the hardware that fits in this hole. So here's my graphical reminder of the types of holes. Counter bores have an area where the head of the bolt can sit. Countersinks are for screws that have angled heads that do end up flush, but they don't need the extra room of a counter bore. A plain hole is exactly what it sounds like. Threaded holes or straight taps allow you to screw into the material. And then you can continue here. Tapered tap. This is a legacy hole, which is 100% custom. If I choose a legacy hole, I don't have to choose my hardware. I do have to choose this shape, and then I custom insert the dimensions. So if you don't know exactly what hardware you're going to put in the hole, but you do know what size it is, this is a good option. So we're going to do simple holes, and I would like to do an ANSI inch. So I choose my standard. I choose my type. I'm going to choose, let's say, numbered drill sizes, and I'm going to make this, oh, you know what? I'm going to make it screw clearances, actually. So we're going to fit a screw through this hole, not screwing into the hole. And I'm going to choose a 1/4 inch hardware. So that would be a 1/4 20, for example. And then I'm going to click this custom sizing to see what it interprets this as. Sometimes SolidWorks doesn't do this well. And if you're looking to get exact or precise in your hardware clearance or hardware threaded fittings, I'd recommend that you go to an internet search and look up a drill chart. So let's just take a quick look. So drill size charts are pretty easy to come by usually. People who sell hardware want you to be able to access a drill size chart. This is metric, so that's probably not from the US. Let's see if we can find an US. And it is a little small. Here we go. So an 1/8 inch, 1/4 inch. Oh, this isn't exactly what we want either. I'll post a good link to a drill size chart, but you can always double check because SolidWorks sometimes has its custom sizes or its sizing a little bit tight, I found. End condition is how far the hole goes through the part. So if it's a clearance hole, it should go through the part. And finally, positions. It has forgotten where I want it to be, so I'm going to reselect this face. And I'm going to make a whole sketch now because I want to make a circular bolt hole pattern. So I choose a circle. I'm going to, on the left, make this for construction, so it's not actually part of my feature, but it's going to inform where my points end up. And then I'm going to use lines, and I actually have center lines here. If I select this down, and I'm going to make some lines at 45s. If I double click, I can start a new line. And because I want to put one hole in each corner of this plate. So I'm going to make these perpendicular by control clicking the lines. I'm going to, I'm going to need a vertical center line. And so now I'm going to Smart Dimension, and this is the first time we've done angles. So I select one line and then the next, and I'm going to make that a 45-degree angle. And because they are perpendicular lines, now everything is at a 45 from horizontal or vertical. So I can choose the point tool at this point and put one hole at the end point of each of those lines. So I've selected my type, I have defined my positions, checkmark puts it in. And it's kind of big hardware for a 3/8 bearing, right? But the thing that is special about the hole wizard is when I go to make a drawing of this part, SolidWorks already knows the hardware that fits in this hole and will remember the quantity of holes that I made, and will also save the depth information for the hole. So I can add something called a hole callout that informs the machinist what type of hole, how deep the hole is, and how many of those holes there are. That should seem to you to be very helpful if you've ever tried to cut a hole in a part. So that's the hole wizard, which hopefully you can see is very unique compared to a cut. Now, if I decide, you know what, 1/4-20 hole or 1/4-20 hardware is just too big, I can edit the feature. Let's say I really want number 6 hardware. We have a lot of number 6 hardware in the shop. We're going to quick show custom sizing. 144 seems all right. I put a check mark here, and it updates all of my holes very quickly. And so that is the hole wizard. So last bit, maybe you want to smooth your edges or put in some chamfers. These are the last features we'll look at, and then we'll finish saving our files here in a moment. So I'm going to come back to SolidWorks. If I wanted to fillet the edges here so that there were no sharp edges, that's not something I do in a sketch, it's just a feature. And under feature, a fillet is also chamfer. So a fillet is a round. I know it looks like fillet for some of you who've never heard of a fillet before, but for whatever reason, spelled the same, said fillet. And then chamfers are just corners taken off. So there would still be sharp edges, but there would be a corner taken off. So we'll show you a fillet first. I select the corner I want to fillet. I select its radius. I usually put on full preview so I can see what it's doing. And now I have a nice smooth edge. Okay, as opposed to a chamfer, let's take a look at that. I select the edge I want to chamfer and the angle of chamfer, or its distance from the edge of the chamfers. Maybe I want that to be 0.25. So I set the two distances and checkmark puts it in. Now I have a chamfer. So I think those are probably the last of these features to look at. There are certainly more advanced things that you can do. Feel free to check them out. But the very last thing for saving your part I want to show you is how you add a material and look at the mass properties for that part. So I've mentioned already, you keep aluminum plate in the shop. So I'm going to right click on my part tree's material and edit material. And you're going to see we have all sorts of materials to choose from. So if you're working with wood or with plastic, you can choose from predefined materials in SolidWorks. We tend to use 6061 alloy aluminum. You can choose 6061 alloy. The different types of this single alloy have slightly different properties, but 6061 alloy is usually specific enough for us. Apply and close. You might notice that the part changes its appearance a little bit, but what definitely changes is if I click on the Evaluate toolbar, I can now weigh my part. So I would expect this part to weigh about 1/10 of a pound, and I can find its center of gravity, which should be pretty close to the center in the XY, and then it's right in the middle of the part in the Z, which is 1/8 of an inch. So that's SolidWorks is keeping track of all of that. By defining my material, when I give a bill of materials or a request for material to the lab coordinator, it's easier to make sure that we have this material in stock. This is a request for 1/4 inch aluminum plate, right? So that concludes the video on SolidWorks part files. Make sure you save it. But hopefully that's enough to get you started here.